my YouTube channel Your Average Coder. This is your host Pratik Nandani, and today in this video we'll learn about introduction to data structure and algorithms. So the question arises is what is data structures? Data structure can be defined as a group of data elements which provide an efficient way of storing and organizing the data in the computer so that it can be used efficiently. Data structures are widely used in almost every aspect of computer science. Now, let us take a look at the need of data structures. The first one is processor speed. To handle very large amount of data, high speed processing is required. But as the world is growing at a fast pace, data is also growing day by day to the billions of files per entity. Processor may fail to deal with that much amount of data, but here comes data structures to efficiently manage such big data. Second one is data search. Now let us consider an inventory size of 106 items in a store. Now if our application needs to search for a particular items, it needs to go through 106 items every time, which results in slowing down the search process. Now if we use data structures, we can efficiently find that particular item in very low time. The third one is multiple requests. Now let us consider an example of Google's search engine. Thousands and lakhs of users are searching data simultaneously on a web server. Then there are chances that very large server can also be failed during the process. But by using data structures, we can manage multiple requests efficiently. Now let us look at the advantages of data structures. The first and foremost, as I already mentioned, is efficiency. But efficiency also depends on the choice of the data structures we use. The second one is reusability. Data structures are highly reusable. That means we compile the data structure in a different library, and the same library can be used in the different client programs. Third one being abstraction. Data structure is specified by the ADT, which provides a level of abstraction, which means the client program uses the data structure through interface only without getting into the implementation details. Now let us have a look at the data structure classifications. Data structures are mainly classified into two types, namely primitive data structures and non-primitive data structures. In this video series, we will look at non-primitive data structures. Non-primitive data structures are mainly classified into linear and non-linear. The linear type of data structures are again classified into two types, static and dynamic. The example of static data type is array and of dynamic data types is linked list, stack and queue. The example of non-linear data types is tree and graph. So now let us take a look at linear data structures. A data structure is called linear if all of its elements are arranged in a linear order, that is, in a non-hierarchical way, where each element has a successor and predecessor except the first and the last respectively. Some types of data structures are given below. First one is array. Array is a collection of similar type of data items. Second one is linked list. Linked list is a linear data structure which is used to maintain a list in the memory. Third one is stack. Stack is a linear list in which insertion and deletions are allowed only at one end, called top. Fourth one is queue. Queue is a linear list in which elements can be inserted only at one end, called rear, and deleted only at the other end, called front. Now let us look at some operations on data structures. The first one is traversing. Traversing means visiting each and every element of the data structure in order to perform some specific operations. The second one is insertion. Insertion can be defined as the process of adding the elements to the data structures. The third one is deletion, which means the removing of an element from the data structure. The fourth one is searching, which means the finding of the location of an element within the data structures. Fifth one is sorting, which means arranging the data structure in a specific order. And the last is merging, which means when two lists List A and list B of size M and N respectively of similar type of elements clubbed or joined to produce the third list, list C of size M plus N, then this process is called merging. Now let us take a look at algorithm. An algorithm is a procedure having well-defined steps for solving a particular problem. Algorithm can be defined as finite set of logic or instructions written in order for accomplishment of the certain predefined task. It is not the complete code or program, but it is just a solution that is the logic of a problem which can be represented either as an informal description using a flowchart or a pseudocode. The major categories of algorithms are given below. Now let us take a look at performance of an algorithm. Performance of algorithm is measured based on two main categories. First one being time complexity. It is a way of representing the amount of time needed by a program to run the completion. The second one is space complexity, which means the memory or a space required by an algorithm during the course of its execution. Now let us take a look at the characteristics of an algorithm. An algorithm must follow the mentioned below characteristics. First one is input. An algorithm must have zero or well-defined inputs. Second one is output. An algorithm must have one or well-defined outputs and should even match the desired output. Feasibility. An algorithm must be terminated after a finite number of steps, which means it should not enter an infinite loop. Fourth one is independent, means the algorithm must have step-by-step directions which is independent of any programming code. The last is unambiguous, which means an algorithm must be unambiguous and clear. Each of their steps and input-outputs must be clear and lead to only one meaning. Thank you for your attention.